In this video, we are going to learn about molecular mass and formula mass. We will see the differences between the two and learn how to calculate them. Molecular mass refers to mass of one molecule of a substance, and this is calculated for covalent compounds. In covalent compounds, elements combine to form individual molecules. Say, for example, water. One molecule of water has two hydrogen atoms and one oxygen atom. And these molecules can exist independently. But of course, there is attraction between the water molecules, which keeps them in liquid state. So water is in liquid state because of the weak attraction between the water molecules. So in covalent compounds, you have individual molecules, so you can calculate the mass of individual molecules. So mass of one molecule is molecular mass. To calculate molecular mass, we just need to add up the atomic masses of the elements present in that molecule. Say, for example, methane. The formula for methane is CH4. So to get the molecular mass of methane, we need to add up the atomic mass of carbon and hydrogen. So atomic mass of carbon is 12.011 and atomic mass of hydrogen is 1.008. But since we have 4 atoms of hydrogen, we will have to multiply that by 4. So once we add up the atomic masses, we get the molecular mass, that is 16.043 U. Similarly, if we want to calculate the molecular mass of glucose, one molecule of glucose has 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. So we need to be careful and we need to make sure that the atomic mass of carbon is multiplied by 6 because we have 6 carbon atoms. Atomic mass of hydrogen has to be multiplied by 12 and atomic mass of oxygen has to be multiplied by 6. So once we find out the products, we add it up and we get the molecular mass of glucose, which is 180.162. Now this is the molecular mass of glucose, which is rounded off to 180. Similarly here, we round off the molecular mass of methane to be 16 U. U stands for unified mass. Formula mass. This is calculated for ionic compounds. In case of ionic compounds, we know there are positive ions and negative ions, which are arranged in three-dimensional structure. These ions don't exist as individual molecules. They do not exist as individual molecules. They are always present in the form of a three-dimensional structure, in the form of a crystal. Now, for our simplicity's sake, to make things easier for us, we write the ionic compounds by taking the simplest ratio of the atoms. We try to get the simplest ratio of the ions and we create our own formula that is referred to as formula unit. Take an example. The simplest of all, NaCl. We know in NaCl we have Na plus and Cl minus ions. Now, if you look at the arrangement of Na plus and Cl minus ions in the figure, every Na plus ions is surrounded by 6 Cl minus ions, and every Cl minus is surrounded by 6 Na plus ions. We don't see that Na and Cl, one Na plus and one Cl minus, are existing independently. They are always present in the form of a crystal in a three-dimensional structure. We take the simplest ratio between Na plus and Cl minus, which is 1:1, and we write the formula for NaCl as sodium chloride as NaCl, because the ratio between the ions is 1:1. Calculation part remains the same. Just like how we calculated molecular mass for one molecule of a covalent compound, we will calculate the formula mass in a similar fashion. That is, if I want the formula mass for NaCl, all I have to do is add up the atomic mass of sodium and atomic mass of chlorine, which comes to 58.5. Atomic mass of sodium is 23. Atomic mass of chlorine is 35.5. So when we add up, we get the formula mass as 58.5. The difference between molecular mass and formula mass is that molecular mass is used for covalent compounds, whereas formula mass is used for ionic compounds. It is formula mass, it's just the difference in the terminology. Since we have individual molecules here, we can refer to it as molecular mass. In case of ionic compounds, we don't have individual molecules, so we make our own formula unit by taking the simplest ratio of the ions. So since we are calculating mass of the formula unit, we refer to it as formula mass. So calculation part is the same, only the terminology is different. Here are two practice questions for you. Calculate the molecular mass of ethanol and ethane. Calculate the formula mass of calcium oxide and potassium carbonate. Leave your answers in the comments section below. Thank you.